এখানে এন্ড স্ট্রিং আছে, ঠিক আছে। Yes, good morning. So please join. So can you hear me? Can you hear me? Yes, Sharupa, Disha, Kakuli, Shashwati, good morning. So can I start? Please tell me, can you hear me? Am I audible? Please tell me. Okay, Shubhodip. Thank you. So G inverse generalized inverse let A of order m cross n, x is a vector whose order n cross 1 equal to beaker of order m cross 1 be a set of consistent equation so I think you know the definition of a system of equation when consistent, that is a system of equation, system of course non-homogeneous equation that is Ax curl B curl, where B curl non-null vector is consistent if and only if rank of augmented matrix equal to rank of A. So this means B curl belonging to column space of A. So that is be a set of consistent equations, that is B curl belonging to column space of A, then there exists a matrix G of order n cross m such that AG B curl equal to B curl for all B curl belonging to column space of A. Then matrix G n cross m is called generalized inverse of or G inverse of a matrix A. So Ax curl B curl is a set of consistent equation, that means B curl belonging to column space of A. Then there exists a matrix G whose order n cross m such that AG B curl equal to B curl for all B curl belonging to column space of A. Then this matrix G is called G inverse of A. For example, take two equations, say x1 x2 equal to 1, 2x1 plus 2x2, this is again 2. So here we see that these two equation, this is a system of non-homogeneous equation and this is consistent, but then here A equal to and B equal to, so it is easily see that B is one of the column of A, hence B curl belonging to column space of A. So if you take x curl equal to 1, 0 prime then we see that Ax curl equal to B curl. Now here G equal to if you take G equal to this, then AG B curl so you see that this is equal to B curl. Again, if you take another solution, because this is a consistent but it has an infinite number of solution, so I just take two solution, 1 0 and another solution 0 1, then you easily see that both cases satisfy these two equation. Then here also you see that Ax curl equal to B curl, and if you take G and here G equal to then this imply again we get this. So this 2G, G1 and G2 both G1 and G2 are G inverse of a matrix A. Hence we conclude that G inverse of a matrix is not unique. So please tell me if you have any doubt. Can I erase this portion? Please tell me. Can I rub this portion? Please tell me. Please tell me, can I rub this portion? Okay. Result. G inverse always exists. Let Ax curl B curl be a set of consistent equation that means B curl belonging to column space of A. Let rank of A equal to R if order of a matrix m cross n, then R should be less than equal to minimum of m comma n. Let PQ order of P is m cross R, order of Q is R cross n, be a rank factorization Suraj, I will discuss later. Okay. Yes, actually the exam. Actually, I want to justify the statement that G inverse is not unique. For this, I use this example. Okay. And via this example, this is just simple example. I will discuss later the constructional method of G inverse. Okay, please tell me, are you satisfied with my answer or not? I am waiting. Suraj, are you hear me? I will discuss later. Okay. This is just an example. Okay, thank you. So PQ be a rank factorization of a matrix A. This imply A equal to PQ. Since P is full column rank matrix, this imply PL inverse, we know this result, we knew already. PL inverse, left inverse of the matrix P exist. Similarly, Q is full row rank, full column rank. Okay, full row rank matrix. This implies QR inverse exists. Take G equal to QR inverse PL inverse. Okay. So you see that order of G now in crossing. So now my claim is the matrix G is G inverse of A. If I prove this thing, G is a G inverse of A, then G inverse always exists. Why? Since we already proved in my last class, that is day 8, that is rank factorization always exists. So using rank factorization, we can easily construct G. And if I prove this G is the G inverse of A, then G inverse always exists. Okay. So G is the G inverse of A. For proving this statement, we need to show that this AG B curl equal to B curl. So now start with AG beaker. This is equal to A is PQ, G is QR inverse, PL inverse beaker equal to PPL inverse beaker, since QQR inverse equal to I N. That is identity matrix. Sorry, this is IR, because rank of A equal to R, and whatever that Q, order of Q is R cross N and Q R inverse N cross R. So this is QR, identity matrix of order R. Mind it, PL inverse is a left inverse of P. Please listen carefully. PL inverse is a left inverse of P. So please do not write P PL inverse is equal to I equal to beaker, because if you write P PL inverse equal to I, this is wrong, because PL inverse P equal to IR, but P PL inverse, this is not I, because PL inverse is a left inverse. Okay, clear? Now, since B curl equal to AX curl, just replace B curl by AX curl. Okay. So P PL inverse A equal to PQ AX curl. Now I write PL inverse P equal to IR. So this means PQ equal to X curl. Hence AX curl. This is equal to beaker. Hence G inverse exists. So please tell me if you have any doubt. Please tell me if you have any doubt. I am addressing one by one, okay? Please tell me if you have any doubt. Okay, Suraj. Shashwati, thank you. So, can I erase this portion? Tell me. Can I erase this portion? So, Suraj, one thing. This is also a constructional method of G inverse. Okay. So, I will also give a detailed constructional method of G inverse. So this is one of the constructional method of G inverse. Result. G is a G inverse of A if and only if AGA equal to A. True. Only part, that is G is a G inverse of A. This is given. Kakuli, I do not understand what you want to say. Kakuli, please tell me. Actually, can you write this one more time? Kakuli, can you hear me? Kakuli, please tell me. I am waiting for you. No, this is wrong thing. Okay, because this is not a inverse. Okay, if the inverse exists, then you can only do, otherwise not. Understand? Because you see that this is a rectangular matrix, not necessarily that this is a square matrix. First of all, second thing is, even if it is a square matrix, rank is not a full rank matrix, so inverse may not be exist. Okay, so these are the restriction, so you cannot do this thing. Agree? Please see the order of a matrix, then carefully verify your statement. It is not possible. Agree, Kakuli? Kakuli, can I continue? Are you hear me? Please tell me. Now your doubt is clear or not? Doubt is clear or not? Kakuli, please write something, yes or no. So okay, can I continue? Please tell me, or still have any doubt? So please tell me if you have any doubt, or tell me if not, then tell me can I continue? Okay, thank you. So G is a G inverse of A. This is given, and we want to prove that AGA equal to A. So G is a G inverse of A. This implies AX curl equal to B curl. Okay, this implies A G B curl equal to B curl for all B curl belonging to CA. This is from the definition of G inverse. This is come from the definition of G inverse. If G inverse exists, then AG B curl equal to B curl for all B curl belonging to column space of A. Let A dot J is a jth column of A, where number of columns of A is n, so it should be 1 to n. Then since B is any vector, mind it, please listen carefully, B is a vector which belonging to column space of A. That means B curl can be written as a linear combination of columns of A or the basis in a column space of A. So if I take B curl equal to A dot J, this implies AG A dot J equal to A dot J. Okay. So this is possible because B curl is any vector of column space of A, so we can take any vector in the column space of. That means you can also take columns of A. So this thing is hold. Now A equal to so if G is a G inverse of A, then A equal to AGA. Okay. Now if part, So AGA equal to A given, and we want to prove that G is a G inverse of A. So AGA x curl multiply post multiply x curl both sides, then we get this, and this imply hence G is a G inverse of A. So please, one thing, please remember that you should write A, please do not write D. When you only write inverse, then you use D, otherwise for G inverse you use A, because G inverse is not unique. Okay, so clear? Please tell me if you have any doubt. Please tell me. Thank you. Kakuli, I will try later. It is not possible to remove this thing in this class. Okay, please consider me. Okay, Kakuli. Huh? I will definitely remove this thing from the next class. Next result. G is a G inverse of A if and only if okay, I understand. Okay, please consider me for this day. Next day definitely I solve this problem. G is a G inverse of A if and only if AG is idempotent matrix and rank of A rank of AG. Proof. Only part. That is, G is a G inverse of A. This is given, and I want to prove that AG is idempotent matrix and rank of A equal to rank of AG. Since G is a G inverse of A, this implies AGA equal to A. So if you post multiply G by both sides, we get this. This means AG is a idempotent matrix. Now, rank of AG less than equal to rank of A, because rank, we know the result, rank of AB less than equal to minimum of rank of A comma rank of B, hence rank of AG less than equal to rank of A. Again, rank of A equal to rank of AGA. So if you take this is a matrix A, and if you take this is a B, then this again less than equal to rank of AG. So combining 1 and 2, we get rank of A equal to rank of AG. Now, if part. So, if part, AG is idempotent matrix and rank of A equal to rank of AG, this is given, and I want to prove that G is a G inverse of A. So since rank of A equal to rank of AG, this imply, both sides imply, column space of A equal to column space of AG. So this means there exists a matrix T such that A equal to AGD. Now, AG is the idempotent matrix. This means AG is the idempotent matrix. This means AG square, that means AG into AG equal to AG. This implies if you multiplied, post multiplied by T both sides, you get this. Then AGD means A, and again AGD equal to A. Hence, so using previous result, we say that G is a G inverse of A. So previous result says that if G is the G inverse of A, if and only if AGA equal to A, hence G is the G inverse of A. So this is the homework. G is a G inverse of A if and only if GA is idempotent and rank of A equal to rank of GA. Please do this. This is a assignment. So please tell me if you have any doubt. Otherwise, I rub this portion. Please tell me if you have any doubt. Otherwise, I rub this portion. Thank you, Shubhrojit. Next result. Please tell me the last one. Actually, please write the comment once again. Or only part equation 1. Only part equation 1. See, we know rank of AB less than equal to minimum of rank of A, rank of B. So this means rank of AB less than equal to rank of A and rank of AB less than equal to rank of B. Okay. So rank of AG, here A is A and B is B. So this means use this one or this one. This means here I use this portion. So rank of A. Clear? Please tell me, clear or not? I forgot the name who mentioned. Please repeat equation number 1. So this is the equation number 1. Actually, equation number 1 using this result, obtained by using this result, rank of AB. Okay, Swarnabo, you are asking. Okay, now it is clear, na Swarnabo? Yes. Okay, thank you. Next result, A is the symmetric matrix then we can always get a symmetric G inverse of A. I repeat this result once again. If you have a symmetric matrix, then you always get a symmetric G inverse. Okay. So proof, since A is a symmetric matrix, this means A equal to A transpose, this is given. Now let G be a G inverse of A. This implies AGA equal to A. Now taking the transpose, so AB whole transpose equal to B transpose A transpose. I use this result. Again I use the result. Sorry. This thing should be this, okay? AB whole transpose equal to B transpose A transpose. So this means A transpose AG. So again I use AB whole transpose B transpose A transpose. Then this is equal to this. Since A is a symmetric matrix, this should be AGA, AG transpose A. Okay, so this implies GT, G transpose is another G inverse of A. So now take G naught, which is equal to G transpose by 2. We easily check that G naught equal to G naught transpose. This means G naught transpose is symmetric matrix. Now A, if we prove that A G naught A equal to A, then G naught is a G inverse of A, and since G naught is a symmetric matrix, then we always get a G naught for a symmetric matrix A. Okay, so G naught means G plus G transpose by 2A. This is equal to AGA plus A G transpose A. So since both G and G transpose are G inverse of A, so this should be A plus A equal to A. Hence G naught is a G inverse of A, hence proved. So please tell me, is it clear? Please tell me. Is there any problem? Thank you. Next result. Let A be order M cross N be a real matrix, then A prime A prime inverse A transpose, actually A transpose A transpose inverse sorry A transpose G inverse, because rank of A equal to R, so A transpose rank of A transpose is R, so R less than equal to minimum of A M cross N, so inverse of A inverse does not exist, so I write A inverse G inverse. Okay, so this and A prime A G inverse A transpose are G inverse of A where is a G inverse of A prime and A prime A G inverse is a G inverse of A prime A. So this is, if you see that if A is A prime A, this means order of this M cross M. A is a full, if A is a full row rank, then this inverse, this G inverse nothing but A inverse, and this is nothing but a left inverse of A, right inverse of A. I already I already proved this part in my previous class, and if A is full column rank, then A prime A inverse exists, and this is a left inverse of A. So this result, this is the generalization of this result, which I already proved my previous class. Okay. True. So we know the result. If G is a G inverse of A, result is G is a G inverse of A if and only if AG is a idempotent matrix and rank of A equal to rank of AG. So I use this result. Now here G is this is our G here. So sorry. So this is G. See that this is a G inverse. Sorry, see that A transpose G inverse is a G inverse of A transpose. So this is equal to this portion. This portion nothing but you simplified as, suppose you take A prime equal to B, then B G inverse B, this gives B. Okay, so this means this is equal to A prime A prime G inverse. So this is equal to, so this is our capital G A G. Hence A prime A prime G inverse is an idempotent matrix. Now rank of AG, so this is equal to rank of A prime G inverse. So this is equal to less than equal to rank of A. Again rank of A equal to rank of A prime. We know this result. because column space of A is row space of A same as row space of A prime. So this is equal to rank of A prime G inverse A prime. Use this part. If since A prime G inverse, so A prime G inverse A prime. I use this result. AGA equal to A. This is our A, this is G, this is A. So this now less than equal to rank of take this is A matrix, this is a P matrix, so rank of AB less than equal to rank of A. Again this is less than equal to rank of A prime G inverse. So combining 1 and 2, rank of A equal to rank of A transpose G inverse. Hence A prime G inverse is a G inverse of A. So proving this part, A G inverse A prime is a G inverse of A, we use the result, the assignment part, that is G is a G inverse of A if and only if G is a idempotent matrix and rank of A equal to GA. So use this result, you can prove this portion A inverse A prime is a G inverse of A. So this is your homework. So this is the constructional method, another constructional method of G inverse. So please tell me if you have any doubt, otherwise I wrap this portion. So please tell me. Please tell me if you have any doubt, otherwise I wrap this portion. Orunima, see, I proved just this part. A prime A prime A prime inverse, G inverse is a G inverse of A. I just proved this portion, okay? But your assignment is you need to prove this also another G inverse of A prime A G inverse of A prime. Okay, is a G inverse of A. You need this portion. This is your homework portion. So this is the hint. Okay, use this result. Use this result for proving this is a G inverse of A. Clear? Please tell me. Okay. Moore-Penrose inverse A plus is a Moore-Penrose inverse. This is the type of G inverse, but this is unique. I will prove this later. So one thing I am telling you, all these things, this part done by C.R. Rao, and I think C.R. Rao and Khotri, I think C.R. Rao and Khotri. Okay, so G inverse, this portion invented by C.R. Rao, because mathematician they do not need G inverse, but we are statistician, we need G inverse, because most of the situation our matrix or we use the system of non-homogeneous equation which is solvable, but it has infinite number of solution. For finding the solution we need a G inverse. Okay, so C.R. Rao invent this portion, G inverse and G Moore-Penrose inverse, all these things. So you need to know this, the name C.R. Rao. C.R. Rao and Khotri. So A is a Moore-Penrose, A is called Moore-Penrose inverse of A order n cross m if whose order m cross n satisfies following condition. One, since it is a G inverse, it should satisfy this. Moreover, this is a special kind of G inverse, so additional property of this These are additional property. So these are the conditions. If this 4 conditions satisfy, then A plus is called Moore-Penrose inverse. See that, suppose rank of A R, which is less than equal to minimum of rank of minimum of m comma n, and PQ is a rank factorization of A, order of P is n cross R, Q is R cross n, P is a full column rank, Q is a full row rank, then A equal to PQ then check that this is a full row rank, so QQ prime, order of QQ prime R cross R, hence rank of QQ prime R. This means QQ prime inverse exists. Similarly, P prime P inverse exists, P prime. So you check that this is a Moore-Penrose inverse. This is homework. So proving A plus, that is Q prime Q Q prime inverse P prime P inverse P prime is a Moore-Penrose inverse, you need to check all these 4 conditions. That is, condition 1, this equal to this, you should check this one. You also check this part where A is defined as Q prime Q prime inverse, etc. And you also check this is a symmetric, and this is also symmetric. So you need to check all these 4 conditions. So this is your homework. Result, Moore-Penrose inverse always exists. So if you prove this thing, A plus is a Moore-Penrose inverse, and since A plus constructed by P and Q matrix, and we know rank factorization always exists, hence Moore-Penrose inverse always exists. I repeat once again. First you prove that, for proving this result, you check that A plus is a Moore-Penrose inverse. So you need to check these 4 conditions. All these 4 conditions satisfied if you use A plus as Q prime Q Q prime inverse P prime P inverse P prime, where PQ is a rank factorization of A. So then you can you know the result, rank factorization always exists, so you always construct A plus, hence Moore-Penrose inverse always exists. Okay, so please complete this part. Next result, Moore-Penrose inverse is unique. So before proving this result, this portion clear or not? This portion, please tell me. Before proving this result, Moore-Penrose inverse is unique, please tell me, this homework portion clear or not? Dishari. Okay, Dishari. See, last portion means I think you understand this portion. A plus is a Moore-Penrose inverse. This is the homework portion. You need to prove this A plus is a Moore-Penrose inverse. For proving A plus is a Moore-Penrose inverse, you need to check this all four conditions. Okay, A plus A equal to A plus A plus equal to A plus, A plus is a symmetric, A plus A is symmetric, and then you need to prove Moore-Penrose inverse always exists. For proving this, you already proved that A plus is a Moore-Penrose inverse, and A plus in constructed by using P and Q matrix, where PQ is a rank factorization of A, and you know that rank factorization of A is always exists, hence Moore-Penrose inverse always exists. Okay, Tishari. So homework means you only prove this portion, A plus is Moore-Penrose inverse. Okay, this A plus is Moore-Penrose inverse. Now I want to prove that Moore-Penrose inverse unique. So I start with, suppose there are, this result is not true. Suppose there are two Moore-Penrose inverse, that is A1 plus and A2 plus, B2 Moore-Penrose inverse of inverses of A, then we know since A1 plus is a Moore-Penrose inverse, this imply A1 plus A equal to A. Now post multiplied by A2 plus both side, we get this. I denote this by 1. Again, since A1 plus is a Moore-Penrose inverse, so A2 prime equal to A2 plus transpose. Again, from 1 we write this as transpose Now take A plus as A and this is B, then AB whole transpose equal to B transpose A transpose. This means okay. So since A1 and A2 both are Moore-Penrose inverse, so A2 plus is a symmetric matrix. So A2 plus prime is A2 plus. Again, A1 in plus A1 plus again a symmetric matrix. Since A1 plus is another Moore-Penrose inverse, so A1 plus transpose equal to A1 plus. Therefore, I denote this by equation number 2. Sorry, see that one thing you can see that this A2 plus A equal to, we write this as A1 plus. Hence we get this A2 plus A1 plus. Okay, this is 2. Now A1 plus equal to A1 plus A1 plus, since A1 plus is a Moore-Penrose inverse, so using property number 2 we get this. So A1 plus this equal to A2 plus. So similar way you can prove that this portion A1 plus A equal to A2 plus A, using same way you prove this part. I denote this equation 3. This is your homework, please do it yourself. So using result 3, this equal to A2 plus A2 plus, so this is equal to A2 plus. Hence Moore-Penrose inverse, our assumption is wrong. Moore-Penrose inverse is unique. So please tell me if you have any doubt. So please tell me if you have any doubt. Okay, so Sunday I consider some constructional method of Moore-Penrose inverse. So I want to stop today. So can I stop? If you have any doubt, please tell me. Otherwise, I want to close the stream. Can I end the stream? If you have any doubt, please tell me. I am waiting for you. If not, then I close the stream. Okay, thank you. Thank you. Same to you, Shubhrojit. বন্ধ করে দিয়ে গেছে